So that time, NIE, basically which was a teacher training institute, started, you can say, engaging people who are not from the education background. For example, I am not from the education background. My degree is in plasma physics, and I did experimental plasma physics at the University of Delhi. So I have no link with education in that sense. I did not do any formal education degree. But then my department, that's why it's science, natural science and science education. So we have half the people who teach how to teach. And we have half the people who basically tell what to teach. That means the content wise. And it is the responsibility of this group, the one who tells what to teach, also to come out with research projects. So initially the idea was to provide research projects, high quality research projects, to our own teachers who are learning with us. And then later on we started taking up even directly the students from the school, because once these teachers, they go to school, they want to do research projects, and then they find the facilities are a little bit not so adequate, so they start collaborating with us. So we started training with the school student directly. So I'm going to share some of these experiences that how the student research or activities in involving students in research started. I mean in Singapore, or what is the current status and how do we do it. But before that, let me just try to emphasize that this is very important. It's not only important in the sense that students gain experience, but it's also important for students' overall development. And there are many research programs. If you talk about 10-15 years ago, if you do Google was not there, of course, Google was. But even 10-15 years ago, there were already programs where universities were training their own undergraduate students in research. So they realized, doing research is a very important component for learning science and engineering, mathematics in particular. So they were offering a program for what you call as the undergraduate research experience. It's called URE, undergraduate research experience. And if you do education research, you can find many research journals, many papers written on that. But now the trend is to expand this, because they notice that not only undergraduate students are keen for research, but school students. So if you go and just do a Google, you will find all the top universities, including NTU, NUS, and maybe many from, from Indonesia. But I simply did a Google search, and in the first click itself, you will find all top universities of the world are offering summer programs, continuous program for a year, 6 months, to train high school students in research. I'm using this is the program from Boston University. They have been doing it for the last 35 years. And this is just a summer program. They do it for 2 months, 6 weeks basically. But they do it quite regularly. And their idea is basically to give students some kind of an experience that what is the campus like, what they are going to face when they come. And also they come in contact with some researchers. This is from the Northwestern University, again a high school program. STEM stands for Science, Technology, Engineering and Mathematics. Basically catering to students who are interested in these fields, and they do it regularly. And these are not only exceptions, Stanford does it. In fact, if you go to Stanford University's website, under the high school students program, they have about 17 to 18 programs every year. Imagine the kind of effort they are putting in. But we have about 3 or 4 programs, not more than that. But some universities in the West, they are heavily targeting these young students to motivate them to continue to, take up the field of science. I think you all know it's probably a common experience everywhere. I don't know about Indonesia so much so, but we have noticed in Singapore the number of students trying to read science has reduced. even in that, the number of students who take up physics has gone even further down. So, is that happening in Indonesia as well? No? Okay, you have lots of science students, that's good. So, you are basically in an advantageous position in that sense. Because in Singapore, people now, students like studying economics and other courses which are like more market oriented. And similarly, other examples, Princeton universities, they also have this. If you look at their research opportunities for undergraduate students, for graduate students, and for high school students. So, basically what I am trying to impress upon you is that this is becoming very, very important, or it has already become very important, and it is the right time for all of us to contribute to this, to jump into this, to make efforts to do these kind of things. And if there is a need for some kind of a structured program, then we should do something to do that. And I think this is a good avenue that all of you have come together. That is a sign of that we want to put a collective effort to do something like that. And I'm sure you will be able to do something like that. So that's the summary. The top universities, they consider engaging students in research internship or research project-based program as an important task, as an important every year activity. They all want to do that. And if you do literature review, you will find that there are tons and tons of literature which is available, which shows that those students which participate, I mean I'm talking about school students as well as undergraduate students, if they participate in some kind of an intense resource-rich program, I mean now you may not agree with that, you may say that you don't really need big amount of money. That's true, sometimes you can do research using very simple things, but what you need is a structure. Because what structure will do, it will provide you a guidance how to do it. There are certain timelines, there are certain schedules to follow. So if you do something in a structured way, that means if you know what I have to deliver by what time, the outcomes will be better. You will be more motivated to do it. Your students will also feel happy because they will also get some certificates. Maybe they will participate in some conferences or some symposia, some program. So that will act like a motivation for them, further motivation. To engage students, of course, the very good ones who are very motivated, self-motivated, they will come to you. But there are some who are always hesitant whether I should do or not do. So if you have a program in place, they may apply, they may take up, and then they may succeed. Sometimes they do better than the better ones. You know, average students sometimes they do better. So that's why we try to work in some resource-rich programs. So when you have a structure in place, you will generate resources collectively, and then the outcome will be better. And one of the way of doing it, of course, like what is mentioned over here, is that the students normally will do these kind of programs under some kind of a mentorship program. That means there should be some mentor, there should be some supervisor to help them to go through this research experience who will guide them. And this is important. Singapore, as I told you, decided to do all this a long time ago, and they want their students to be 21st century learners. That is, they should learn to explore, they should be innovative. I was not able to understand most of the talk before one, but I could understand it was written in Indonesia, innovation, and everybody is talking about innovation. People who can do things on their own. So you want to provide a platform to these young ones. So these are the right avenues in that case. Okay? Yeah.
May I add something? When you are researching plasma physics, do you still need a fresh idea even from a high school student? Maybe?
Okay. In that case, because the students normally don't have a background in plasma, we provide them a project, but student is given the freedom to change the project. First he tries to learn something from us. Once he knows something, once he is trying the project, then he can plan himself to do anything other than what we have initially planned for them. So I'm going to talk about this, what you have asked, a very good question. I have that in my list. So that is what I call as a structured program, which have limitations as well as some advantages. So I'll talk about that. Yeah. Any other one want to ask anything? Okay. So the point is that the students are going to benefit a lot from this. It's not only they learn more about science by doing project. It is a development, overall development. It's like intellectual benefits they get personal benefits, they get professional benefits by participating in these kind of structured programs, research-based programs, which we need to design for them. Okay, and definitely how it is or how it does. I mean, how it does a good job for them. Many education researchers are interested and they do research on that. Of course, I'm not on the education research side. I'm basically like a worker. I just work with the student and the outcome normally comes out of that. So it's a common experience and also a documented fact that it's one of the best ways of engaging students, and not only engaging students to develop them further, to develop their full potentials, including of course the character building. Now, here onward, I think this is just some basic fundamentals related to that. What I'm going to do is I'm going to share my experience in Singapore related to that. So I'm going to talk about some of the programs that are there. There are many actually in Singapore. I will talk about few of those with which I have been associated with, but I will take only one or two examples because it's not possible to take all of them. So we have various mentorship programs under which the students can take these projects. What are the various things? Then once we decide that okay, we want to give a project, then how do we plan a project? Okay? Then how do we execute the project? And then whether the experience that they get the project is enriching one or rewarding one or not. See, they, in the end, the students all want some kind of reward. It's not only the reward in terms of the scientific knowledge gain, but it should be a reward in terms of what is useful for them in future. You know, they should be able to get some mileage out of it. And it's not only the students who get the mileage out of it. Let me tell you very frankly, we gain a lot more than what they gain. Let me tell you. So if you are, I heard it during just now the lunch break, all of you are very motivated, self-dedicated, and you are working on your own. And sometimes some people may tell you that, oh, why you are wasting your time? You know, government is not giving you any money for that, you are not being paid overtime, you are not getting anything gainful. Right now probably you say, oh, I only do it because I like it. But I am telling you, liking is good. But if you plan it properly, you can gain a lot by yourself. And I will give you some example for that. How did I gain a lot myself by working through these kind of projects? I have worked in more than 100 projects with more than 100 students on this. So I'll share my experience with you. So I'll go one by one. The first one, that what kind of avenues we are providing to students in Singapore to work with programs. I'm talking about over here the structured program. In fact, in addition to these structured programs, I also work in a non-structured program, because these programs, which are structured programs, are only open to schools which are under Ministry of Education in Singapore. But Singapore is an education hub. There are lots of international schools. And these schools also, they want to, they can't apply to these programs, but then they approach us. Sometimes even from these schools, which are MOE school, ministries school, but these students, because of the limited number of seats available in these programs, they come to us separately. Their teacher writes to us, my student is interested, can you help? So we also work in those programs. So I'm going to talk mostly about the structured programs. And these are the programs like Science Mentorship Program, This is a program which is run by the Gifted Education Branch of Ministry of Education. Then we have a Gnanam Research Program. So this is a ministry-based program. We have a Gnanam Research Program, which is basically a program run by my university, NTU, Nanyang Technological University. And why NTU does that, I'll explain it later. Then there is a similar program by the other main university, NUS, which is called as SRP, Science Research Program. And then there is a program by a Defense Science Organization, where students are able to work with the defense scientists as well as with defense scientists and university professors together, as well as rescue teachers. In all these programs, they are done at the tertiary institutes, that means at universities or research labs, but school teachers are involved right from the step one. It's their role to send the students, select the students, and when we are doing projects, they watch their students, they have to monitor them. And they sometimes, some of them, they are very keen, they also join the project, and then we work together. So let me show you some of these, some information about these programs. This is Science Mentorship Program from Ministry of Education. You can see Gifted Education Bank, Singapore government signed over there. And just some highlight. So the mission of this program is to develop interest and talent in scientific research. And this one targets very young students, basically before secondary 4. Secondary 2 and secondary 3 as well as secondary 3 and secondary 4. And the students in what we call as the integrated program, where they go directly from secondary 3 to JC. And the structure of this program is that it is done at 2 levels. Those students who are from secondary 2 and secondary 3, they do it in school. So their teachers are their mentors. Those which are slightly senior, they go to many different institutes, including NUS, NTU, and many scientific institutes. So these are properly structured programs in the sense that there is definite schedule. The students are selected by school, their teacher, then they send to ministry, and the ministry approach universities, different institutes. They ask them to propose a project. Then the projects are displayed on the website. Then the students apply. One project, there are 10 students apply. Then we take interview. And then we select. Okay? And at the school level, definitely there are more options. The students can do more projects. And the one which is done at the university level, the criteria is slightly different. So this is school students project. They are basically investigative science fair project. Whereas when it goes to the university level for the school science topic, then the nature changes, cutting edge science. Some of these students, they really work with some good teams. They are very high IQ level students, and they do really very good job and come out with some fantastic work. So they work 3 hours a weekly. 3 hours a weekly is just a rule. Normally it's not like that. I mean, I have taken many students under this program. I tell them, okay, you come on Saturday, basically full Saturday. Because if they come after school hours, then they travel to NTU, because NTU is in the western part of Singapore. Travel time is almost 1 hour to 2 hours. By the time they reach NTU, it's already 4 or 5 p.m. Then they want to go back after 1 hour. It's not feasible. If you want to do any research-based project, you cannot do it in half hour today, half hour tomorrow, half hour next day. It doesn't work like that. You have to do long hours in one stretch. So we normally do it on Saturdays or on the days when they are free. This is a program by Nanyang Research Program, NTU. I can share some information about this because I am associated with this ever since I joined NTU in 2001, and I was a treasurer for this program for almost 5 years, and our institute also was the organizer for this for 2 years. This program has been modified. Initially it was called TERP, Technological and Engineering Research Program. So only technology and engineering, but now the program has been changed to called MRP, Nanyang Research. So arts is there, education is there, any other project you can think about in research, they are all there. So not only technology and engineering. This is full 1-year research program, very structured. Once again, the university make a call for the project from MPU schools, different schools in January. Then the students are nominated by schools through Ministry of Education. Then there is a selection interview, and then they release the name list. Then the students are given a training, a lecture series, that how the projects are done. These are theoretical lectures. That means the student learn about how to do, say, suppose, what are the things they need to take care when they are doing some experiment. Because if you go and attend some projects being done at the secondary level, they may take only their experiment only do one time. Normally you want to do statistically as many times as possible. So we basically tell them the importance about what are the proper rules, what are the proper ways of doing any proper research experiments. Because the idea is to train future scientists. Not only we are satisfying their, their zeal to do good science, but also we want to train them to become a better scientist. So the lecture series are given to them. They are told about data analysis. They are told about error analysis. They are told about what are the good practices of handling the equipments. What are the ethics in the lab that one needs to follow, and so on and so forth. So that's done collectively for all students. Normally we select 100 students. So there are about 50 to 70 projects every year offered to the students. And then the students, they start doing projects from April all the way up to January. And in January, in between, they submit a progress report, how they are doing. And then finally, there is a symposium. Symposium is attended by all the students, where the prizes are given. So these are the categories. So not only engineering, but basic sciences, and also you see the art design, art social science, business, these are also included. So it's a very wide scope program. And as I told you in the seminar series, okay, what is the good point about a structured program? So they are not doing research just as a hobby. See, we want to develop many skills in them. One of the skill over here is writing research paper. That means at the end of this program, they have to write a research paper. To write a research paper, they need to read research papers. So what are the practices that need to be followed? They follow that. Then they do a poster presentation. So this also helps them to become a better person, in the sense that their communication skills, they become better. They know how to communicate. They know how to present. Each one of them is given 10 minutes time. So they have to do everything within that 10 minutes time. So they need to do planning. So they do many mock-up sessions to do that. So the point is, it's a research program, but it's leading to an overall development of the student, because it is very structured and it is properly conducted. Of course, each project is given a research grant. We give them about 1,300 Singapore dollars for each project. So yeah, that's a very good amount. That's why this amount is not to motivate students, but motivate teachers to take up this, because 1,300 is a good amount, even for us over there. We can buy many things from there. So universities spend almost $100,000 per year on this program. And not only the students get that grant, they also can claim transport. That's very small amount. And of course, some other things. Look at the time they need to spend. It's a very big program. They need to spend at least 120 hours. But let me tell you, once you are able to motivate the student, this 120 hours is nothing. Many of them, they work 300 hours, more than that. You have to tell them, you don't come to my lab anymore because you are not allowing other people to do work. These people sometimes, they are so motivated and they get used to it. But not always everyone is like that. Some of them, they are not really that, they just work for the certificate, then it's not good. So as I told you, the process is, so they are properly assessed using different criteria. Okay, so that is about some structured program that we have in place. And the good thing about these structured programs is that they provide you a sequence, they provide you a method, they provide you a platform to do this job. That is very important. And since many of you are collectively sitting over here, you should think and plan something to do something like that. Because TERC program was also initiated only by a few professors from different schools. They formed their committee and they did it. Initially no money was offered. But university later on realized this program is very good, giving lots of outreach to the university. Students are coming to NTU, some of these students then later on join NTU. So university realized, oh, this is a good program. Then they took over the programs. Now the program is not anymore handled by the professors committee, it's handled by the students affairs division. And they have their own managers handling these programs. Not only their own managers, later on they expand even the program more. They included what is called as the Ministry of Education's H3 programs. H3 is the highest level of courses that you can take in Singapore for school students. So, a non-structured program developed into a very, very structured program. 5 years ago, when the university was not overtaking it, there was no website. Now everything is done online. We do everything, no need to go anywhere, no need to send anywhere, everything online, submit paper here, get the information over there, and you can go to the website of NTU, you will find this. Just type NRP Singapore, you will find the information. So that's the good thing about working with a structured program or creating some kind of a structure. The next thing is about some other basic planning. This is also very important because this is for you. That one is maybe for people who want to develop the structure from the organization point of view. Now, when you want, suppose you want to take up a student and do a program, do a research program. There are two ways. Either you do a project which the student wants to do. He wants to do something. He has some crazy idea. He wants to do that. But you must evaluate before saying yes or no. Whether you can really help him or not. Whether you have really resources, background knowledge to do that. If you can't, please just tell him very frankly, sorry, I cannot help you. Why? Because it's good to not to give wrong ideas, wrong direction. Or just clearly accept, I can't do this. But then if you can help him, if you know what he's talking about, or if you have some interest in that, definitely must do it. The other way is like, because I am talking with reference to the structured program, and in this structured program, normally we have to propose project. So we get a time, they give us about 1 month, they will send us an email, please whoever want to apply, or give a project, give. So we give. Nowadays the competition is so much, they want us to make a presentation. What is the project you want to offer? So that you have to carefully think about the project. Because so many people are interested. So you plan early. So normally we offer project based on our expertise, which will be evident from what I will show you later on. Some of the projects are related to our ongoing research, which I am interested in. So in your case, you can think of in your ongoing, what you can say, interest, if you don't have a research grant. But some of the projects may be related to what we want to do in future. Some of the ideas we hear, oh, this thing is something I heard and I can do it, but I don't have the time to do it. And how to do it? I don't have resources to do it because I don't have funding for that. So I will do it to students. Because I want to do it and I want to apply a research grant in this field. Any research grant we apply in Singapore, we have to show that we have some initial research. We have done something related to that. So this is a good avenue that we plan accordingly, and I will show you some examples. And some projects we can, test our hypothesis. Okay. As I told you, I have been working ever since I joined Singapore as this. Basically, I am from University of Delhi, India. I was working in University of Delhi up to year 2000, and I joined joined Singapore in December 2000. So January 2000, the very first month, I got an email, do you want to apply for a project? I said yes. So I gave a project on this. If you look at the list, I'll try to explain what I was telling you just now. Everything will be maybe French to all of you, don't worry about that. Because the projects have some keywords. This is related to my field of expertise. So when I first came to Singapore, I did not have any money, so I gave them a project on, this device was already there, it's called plasma focus, don't worry about what it is. But then I gave the student a very simple project, make a magnetic probe and measure the speed of the plasma in that. And magnetic probe is nothing. You take a wire, open a wire, cut it out, you just roll it in a coil, it becomes a pickup coil. So when the current passes, magnetic field is there, this pickup coil kicks in and you measure it on the oscilloscope. That's it. But I gave them an idea that, oh, let's probe, rather than putting 1 or 2 probes, let's put 7 probes, one in the sequence. Because in India, I did not have a very good oscilloscope. In Singapore, they had a very good oscilloscope with 8 channels. So I can put 7 probes and 1 signal as reference. And if you look at the first 7 projects, they are all related to plasma focus, plasma focus, plasma focus, plasma focus. That's the field I did my PhD, and that's what was there in the lab. So what I was trying to tell you, start in something where your expertise is. And then I start changing, and even in these, the field, the projects are not same. Look at the first project. It's the current shift curvature measurement in plasma focus. Don't worry. Second one was measuring X-rays from plasma focus. Third one was measuring ions from plasma focus. Fourth one is some X-rays which is similar to plasma focus. Then neutron. Different diagnostics. So I use these students to help me develop these diagnostics. These are very bright students, you know. And if they are motivated, they can do wonders for you. So it's a win-win situation. So these are the 13, this year I have 2 projects from this program. Okay. Alright, let me go further first. Now, as I was telling you, I try to do a project which are related to what you are interested in. And you are not only helping students to learn something new, you also should have benefits in that. So, as I was telling you, we do projects which are related to our expertise. So, first projects were basically all related to these 2 research projects that we got from A-STAR as well as from an external International Atomic Energy Agency. So, while we work with these students, we try to achieve the targets which we gave in these projects. So, that's why we were working on that. And some interesting things. After 2007 or 2008, you can see the next few projects are not related to plasma focus. Now it is like nanostructure making using vapor transport method, nanostructure using atmospheric plasma, nanoparticle using atmospheric plasma, nanofabrication. Because somewhere around 2004-05, nanotechnology started to come in a big way. And we also have to change our, not field, but change the ideas to work in the fields which are more relevant. It's not that I also only wanted to work. Because I noticed when I'm putting up the plasma focus project, students are not very keen to take it up. They want to do something which is more in the market. You know? So nanotechnology was in the market, so they also want those kind of projects. So you have to think and work accordingly. So I will come to these things. So one way is to work on the projects which are basically from your field of interest. The other way is, if you don't have a research lab, you don't have an ongoing field, then how do I go about it? Right? That's what you can say. You can say that, oh, this should not work with me because I don't have a research grant, I don't have a research established lab. What should I do? Then what you do is that you pick up some journals. And from physics, I can give you an example. We normally follow this American Journal of Physics. There are lots of high school projects in that. Of course, these projects have already been done, but you can always modify them. And these projects are not very cost intensive because these are for undergraduate laboratories. So you can pick up a project from there and you can do those projects. And these projects normally can be quite complex, can be simple also. For example, this project, determine the speed of sound in various media. It's very interesting for the school student. So this project, if I share you, was very simple. This project just simply involved using two speakers. So there is one speaker which acts like a source from where the sound comes. Then there is another speaker which becomes like a detector. So you want to send a sound pulse, so you need to make an electronic circuit which generates a sound pulse, just tick like that, tick. So when you send it, you note down the time in the oscilloscope when are you sending the signal. And then the other one picks it up and then you measure what is the time difference, that's all. See the difference. It was a very simple project but was not so easy to do because you need to make a circuit, design a circuit which just sends a sound as a tick, one signal. Because if it is continuously going, you do not know when does what starts. So how do I measure? This is called time of flight method. So the students need to design a circuit over here. The student need to design a circuit over here to pick up the signal. Because the signal was so weak because we were just using $12 microphone available from Siemens Square to measure it. And you need to make an amplifier circuit. So they learned that about operational amplifier. So these kind of experiments, projects, they do not need any research time. But you can do still very good job. Like the next one, determine Planck's constant using a single filament light bulb. So this one was maybe less than $10. All you needed was a spectrometer which was already there in the lab, and you just needed light filament and you do an experiment systematically, think about it, it can be done. Of course there was a complex one, laser interferometry. I think I have it over here. This was the project, laser interferometry of gas jet. This was a complex, not easy to do. So in this case we need a laser, but nowadays laser is not difficult. 10 years ago green laser was $100, nowadays maybe $20. Oh. Yeah. So it's not difficult, yeah. So over there we use a continuous laser, helium neon, and we just have a gas cylinder, open the gas cylinder and let it come out through a small nozzle, and then you do the interferometry measurements. So from there you can measure the densities. And quite ambitious project. Analysis involved a lot of things. Setup was not so difficult. So this one was also done by school students. There is another avenue you can choose the project from. Have you heard about this? I mean, only the physics people have heard about it. There is something called IYPT, International Youth Physics Tournament. Every year they note 15 problems. Each of them is a research project itself. So if you have no idea of yourself, a student does not have an idea, he can just go and pick up any one of these and can start working on that. They are all very challenging and all very simple. No need any extensive elaborate lab. Some of them are investigate when you take two steel balls, put a paper in between, you leave them, they come and drop, and the paper burns. What is the reason? Investigate what is happening over there. So simple investigative project, but having some deep level, science in that. So a lot can be learned. I'll give you an example of this simple project. Not simple actually. Oops, I think wrong. Okay. This is magnetic force, learning about magnetic force microscope. This problem was given in Asian Physics Olympiad 2010, I think in Taiwan. So they have a very sophisticated setup. They have a piezoelectric crystal to vibrate a cantilever, and then they have a magnets over there which can be adjusted. Then I pick up the student and they were using deep electronics. We just said, okay, if you want to set a cantilever, so okay, what is done over here? There is a cantilever. They had this one connected to some piezoelectric crystal, which vibrates when you provided certain AC voltages, and then it vibrates, and then there is this magnets over there which come over there, and if they come over there, the resonant frequency changes because these vibrate at the natural frequency. The natural frequency length depends on the length. So we change this setup to a simple speaker from a market, and we vibrate it without any, piezoelectric crystal, and set it into vibration, measure the resonant frequency by vibration of the laser spot, and student did lots of investigation over here. How is the elasticity, the length, the stiffness of the material changes the frequency, how the magnetic fields affect that. So this project was motivated from one of the previous physics Olympiad problems, and there are many such examples available. So idea is you can do a very sophisticated project which need a laboratory or something, or you can just develop something which you all are also doing, but I'm just trying to tell you the resources from where you can get them. Okay. And when you plan for the project, of course we want to provide the students some project ideas. The project should be challenging and exciting, Only then they will continue to feel motivated. If you just give them something simple, they will think that, oh, I am being fooled by my supervisor. He doesn't have a time, he cannot think for me, and or he is not trying to help me in my ideas, so I don't want to do. So the program, the project that you are offering must be challenging, some must be exciting, in the sense that must also have some kind of status. Remember just now I showed you the first 7 project I gave you. I was giving to my NRC student related to plasma focus. Now what is the plasma focus device? I will not talk about what is plasma focus device, or maybe a little bit later. This is a recent article in 21st Century Science and Technology. In the very first article of this Creating Fusion Economy, we just talk about the fusion, the future energy resource, where you try to get the energy by fusing two hydrogen isotopes. If you look at the list of programs, if you are not from physics or plasma physics, you may not know what these are, but these are international projects, very big international projects. This is ITER. Anybody has heard about the name ITER? ITER is the biggest project mankind has ever taken. It's a $10 billion project coming up in France, Cardiff, to achieve fusion in a device called tokamak. So ITER called International Thermonuclear Experimental Reactor. Okay, chloride supra is also another tokamak. These are mostly tokamak devices or other plasma devices. These are written tokamak. These are devices which are working towards a future fusion energy as a solution to energy problem. And if you look at that, the last one is written International AAPT. Just now he told me I am the president of this association, AAPT. We are a group of 42 institutes from 21 countries in Asia and Africa. We have one group from Indonesia also who is a part of our group, from the nuclear reactor group. So Professor Suryadi was previously there, now Professor Bibi Usada is our member from Indonesia. But what this group has done, this group picked up a device called plasma focus. I'm giving you some food for thought. A group of people about 28 years ago, they were meeting together in ICTP in Italy, and over the lunch they discussed something that in Asian countries we do not have a facility which is small, simple, where student can be trained and can learn advanced science. So these people, they come out with idea, let's make this device. Then they not only make this device, they give this device to many different countries. And this device is basically nothing but 2 electrodes, one in the center, one outside it, where you pass a very high current by discharging a capacitor, you generate very hot and very dense plasma. Hot as sun. Dense, very dense. And when you do this, when you make this device, and when you operate this device, the beauty of this device is it's very simple. Can be made in 5 $5,000. Initially it was made in $5,000. I was trained on this device. And then I went back to University of Delhi and we made this device. And I did my PhD on this. So within $5,000 we made a device which is such a rich source of many different things. You can study plasma dynamics, you get ions, electrons, X-rays, the first project that you saw. So this device is simple. Simple in the sense it's not very cost intensive, it's not very resource intensive. It's simple but yet very complex. It's complex but it is good. You can study a lot. So on this device therefore, so what I'm trying to say is that if you have something which is challenging, exciting, when we make them work on plasma focus, we tell them, you are contributing towards the fusion science research. So the guy feels very motivated. I'm doing fantastic. He goes, tell his father, tell his friends, tell his mother, I'm not just making bananas or something. I'm not just flying kites in the lab. I'm doing something very, very related. You have to excite them. You don't make false promises, but you need to tell them. They will always go and find and do a research by themselves. So you have to make it exciting, challenging. They should feel proud in what they are doing. That's very important. Then they become more aggressive, then they do more with more intensity. And of course it should be timely and relevant. And as I told you and as I was showing you, there is a progress in the kind of project that we were offering. Alright, we thought that if we just offer plasma focus project, the students are not going to come anymore. So we also changed. So we started working in nanotechnology related because the market is so heavily governed by nanotechnology now. It's almost touching many billion years. It's supposed to touch 3 trillion years by 2020. And nanotechnology seems very difficult. Sounds very complex. But every one of you can do it. I realized it after I started doing it. Okay? I'll show you an example. You just need a pressure cooker sometimes. You can do nanotechnology. That's not very big. But over here my main point is they try to do something exciting, challenging. Try to do something which is also relevant and useful for them. And when you also plan, you also make sure that the students are available, you are available. And when you take up the students, if you are their own teacher, then it is fine. Or if you are trying to train some other students, you basically find out whether he is motivated or not. Now, I have 10 minutes. Okay, now I go faster. Then, how to execute? As I told you, you need to brief students very well. You need to tell them what is the excitement, or what is the aim of your program. You tell them the aim of the program, you give them some resources. They should do their library search. You tell them how to do library search, how to use Google to find out relevant information. Give them some time to read, some time to come out with their own ideas about what they propose. They may come out with something which is very good, or they may come out with something which is, you will say, it's all rubbish. But it doesn't really matter. It will give them some time to read and some time to study what you want them to do or what they want themselves to do. Then, very important aspect of mentoring is that you have to be there. You just cannot leave them by themselves on their own. Particularly during the initial phase, when they don't know what to do, what not to do, it's better. Normally that is what I used to do all the time, is that the very first few times when they are in the lab, I make sure I am available. I will only call them if I am available. I will not simply tell them today you do this and I will come after 2 hours and check what you have done. If I do like that, I won't succeed. Because then they are also not very sure what they have to do. You have to tell them, you have to brief them. Okay, in Singapore the safety is a very big issue. We don't allow students to touch anything unless we have properly documented that they have been trained. So that one definitely needs to be done. We teach them right habits, how to work in the lab. We also teach them how to keep the record. by the way in Singapore we have this rule, any research data that you have taken must be saved for 10 years. Particularly if you are publishing it for what is called as the research ethics point of view. So we have to save the data in the hard copy format. You cannot say, oh, my hard disk crashed, data all gone. I cannot prove whether I took the right data or wrong data. Because sometimes when you publish these days, there have been research frauds. So university have very strict guidelines that when you publish anything, you have to maintain the research integrity. All the data, if anybody wants you to show them, you have to show them the first basic data that you collected. And we teach the same habits to students. We tell them you have to store the data at 2-3 different places. And you have to show me anytime I ask you. So they are taught all this, they are taught about the logging, maintenance, recording, data. Sometimes, nowadays, I mean, as I grow older and my research group also becoming bigger, so I cannot do everything. Students are taken over after the initial phase by my PhD student. But I do like check once in a while. But initially, to motivate them, I have to do it. Then I cannot rely on my PhD student. Need to work hard. Of course, this is, you all know about this because I think you all work very hard and that's why you are here. I don't need to tell you about that. I tell you, I am working in Singapore for the last 13 years. Every Saturday I am here. Saturday is an off day for us. But every Saturday, 10:30 I am there in the lab, not 9 because little bit of relaxation in the morning. And every 10:30 I am there and I will be there till 4:30 in the lunch hour break. So I still work on almost 6 to 7 hours on Saturday because these guys are there. Every year I have about 4 or 5 groups from school. So every Saturday there is 1 or 2 groups where I always get together. So we need to go there and Saturday I will be voted for them if I am not extremely busy somewhere. So definitely you have to work very hard. You have to work very patiently. And post project, the work does not stop at the project, end of the project. We need to do paper reading because we all work under structured program. So paper needs to be submitted, poster needs to be presented. There are mock-up sessions that I arrange with them, ask them to make presentation to me before they go and make the presentation. So it's very difficult to do it all alone. And also, sometimes your ideas are not enough. So normally I work with my colleagues, 1 or 2 colleagues from my own department. So strength and unity is a strength. Then, okay, last 5 minutes, I will quickly wrap it up. Make the research experience enriching and rewarding. There have to be some rewards. Have to be some rewards in the sense that they should get something out of it. And what is it that can be something out of it? Imagine, I published my first research paper when I was a PhD student. But some of these students who are really good, they have published even research paper at the age of 15, 14. These are the research papers published by these students working with me. First 6 are research journals, some of them high impact factors. And look at that. This Farabhay is a very big professor in the USA. We sent these 2 guys, this guy over there, Barry Biden is from my student, one of the JC students. He went to UCSD for 2 months to do project, initially did with us. He was very motivated. And he had funds from his family, he went there. Later on, we all published together a very nice paper with physical sector. Then I have this is my PhD student. This is again a JC student, Linchi. Carl Chandra is an Indonesian boy. Was one of the students, Carl Chandra. And these people, they published a paper in 2005. This is very highly cited paper. It has more than 27 citations, which is quite good. It's not a small amount. So these are research papers that they publish. Some of them they went to international conferences and presented over there. For example, these 2 students, Singhi and Jeremy, who was Singhi, they went to Korea with me to present a paper. So Ministry of Education funded them. They were able to find funds. Then 2 of these boys they went to St. Petersburg to present their paper. So they need motivation, and motivation comes from what chances they have to present their results. So awards and recognition, not only when you work with them, you not only work for self-satisfaction, you not only work for gaining knowledge about science and something, you should work hard for them to get some positive mileage out of it. So you may say, so I may be very vigorous supervisor, I make them work so hard. Out of the 10 students which did TERP project for last 9 years with me, for last 10 years with me, 9 of them they won gold award. This, and when they have this award, it helps them in university admission. Not only in university admission, some of them, 3 of them actually got A-star fellowship all the way up to PhD. Based on the research paper they published. This is a $500,000 scholarship with rewards. They can choose any university in US and UK once they get through this. And these were average students, their marks were not so good to get the scholarship. But their research supported their thinking so much. They got it. And these people are like my lifetime friends. Facebook friend, every friend. They still are in touch. Some of them did 10 years ago. Another guy. So this student now is doing PhD from UCSD. This student is now doing PhD from Princeton. They were all our project students. So, if they receive this award, they feel happy, they feel motivated. So awards and recognition is must. And some of them, of course, they cannot get those awards. They participate in some science fairs like this student. She is studying now in the University of Manchester. She is doing physics. Many of them are motivated, and those which I talked about, they are all doing physics. Out of that list of another 13 students, I think 4 or 5 are doing physics. Big achievement for us to keep them motivated to do physics. They participate in what is called a Singapore Engineering Science Fair. Every year there is a science fair, so they participate, present their results. And if they are the top student, then they get to go to Intel Science and Engineering Fair in US. So far none of my students got a chance to go there, but they all try to work towards that. Well, I think I already talked about this, that we try to work towards our own ongoing projects and projects. And have fun with them also. Let me show you this video. Oh, the sound is not connected.
This program, when investigating X-ray missions in our life, it is a program that investigates some X-ray missions from young astronauts. We learn a lot of things, such as the cost of apparatus, high voltage, CT cameras, imaging systems, and even optical stream photography.
So this poem was from Indonesia. This is the year 2002 batch. I did not look at recent video just to show that this was about 10 years ago. This boy was working with me, and this is the girl who got the A-star fellowship. So they do all these fun activities also in the class. When they are over there. We got together with them not only in the research project, we have our group social gatherings. They also attend our MSc and PhD seminars. We allow them, we take permission to let them sit into this. When we have any lab visit by dignitaries, we always involve them. We involve them in various things, to showcase their own project. We also involve them in some other events, like I'm doing a conference in December 4 to 6. All my project students, they will be there. They will be meeting international scientists. They will discuss their project with them. They are going to present a poster, and they will get the chance to see, and they will, get motivated and excited. So this is like for rewards for them. And question was that one of the things that I wanted to discuss, that is it possible to work on high-end projects? And I think I already discussed it. Yes, it's possible. You can develop some facilities by yourself. That is what I tried to tell you, that we have this AAAPT, where we develop this device, which is now given to 9 or 10 countries. And student works on this using just very simple diagnostics. So if anybody wants to become a group of this member, most welcome. I mean, I am president, you can always enroll, but university people normally. Nowadays, students are, school teachers are not allowed, but university definitely can become the members, and then we can provide training and other facilities. Normally, we can arrange a visit where we can train the things, we can help to provide the facilities. And therefore, the conclusion is definitely it's enriching and rewarding experience for students, and not only for students but us also. I think that's all I